This is a do-it-yourself manual on pilot's experience of how to extract essential oils and useful chemicals from different plant materials, at the Botswana University of Agriculture and Natural Resources, under the Divagree project. This manual contains operational and maintenance instructions. The function of the distillation and extraction process is to extract valuable substances from various plant parts. In this manual, gum resin from Commiphora species and plant parts from Commiphora species, Hyphane petersii and safflower are used to receive valuable chemicals. The objective of this technology is to utilize and valorize residues and selected crops from agriculture to introduce a potential new market sector to the region and create income opportunities for farmers. Here is a short overview of this DIY and operational and maintenance manual. Here is an overview of the chapters in this manual. The components used for the hydrodistillation process of essential oils were heat protection gloves and protective goggles, the do-it-yourself steam distillation apparatus, amber flasks, a digital infrared thermometer, and a separation funnel. To build the steam distillation apparatus, the following tools were used: 20-liter stainless steel electric urn pot, a self-made condenser and condenser pipes made out of stainless steel pipes with a diameter of 16, 32, and 50 mm, a drill and hole bit, a grinder, a submergible pump, a cooler box with a volume of 20 liters, a steel stand to place the still on top, and a wielding machine and rods. For the extraction processes, a thermometer, beakers, filters, and sieves, and different extractants such as ethanol, hydrochloric acid, sodium hydroxide, and bleach were used. When welding the condenser, wear safety glasses for protection from intense light. The bright light from the welding can damage the sight. The metal becomes very hot in the welding process, so safety shoes and heat protection gloves must be worn. When operating the still, heat protection gloves, long clothes, and goggles must be worn to protect the skin and the eyes from boiling water splatters, steam, and hot metal parts. Don't leave the distillation process unattended. Always wear gloves and protective goggles when handling hydrochloric acid and sodium hydroxide because they are corrosive and can cause severe skin damage. Same applies for hydrogen peroxide. Ethanol is flammable, handle it with care, and keep it away from open flames. Essential oils are toxic in high dosages, keep them away from children. The traditional use of medicinal plants is not always scientifically sound. Plants contain various active compounds. Those should be analyzed before extracts, oils, or hydrosol are used for medicinal or culinary uses. The condenser is made up of 3 round, stainless steel tubes. A 32 x 1.5 mm tube connects the condenser to the lid of the pot. The water jacket is made up by surrounding the inner 32 x 1.5 mm pipe with a 50 x 1.5 mm tube. The outer pipe of the water jacket, which is 50 x 1.5 mm, has a cold water inlet at the bottom and the hot water outlet at the top of the water jacket. The inlet and outlet are both made of 16 x 1.5 mm stainless tubes. The water jacket is sealed at the top and bottom by a 50 mm diameter stainless steel disc. The top disc has a 32 mm hole in the center, to accommodate the 32 mm pipe from the boiler. The bottom disc has a 16 mm outlet where the condensate leaves the condenser and is collected. In pictures A and B, the welded pipes of the condenser are displayed. The pictures C and D display how the discs are welded onto the top and bottom of the condenser to create a closed cooling jacket. Picture E shows how the pipe of the condenser is welded onto the lid of the still. In picture F, the whole do-it-yourself still is displayed. On this slide you can see the boiler when connected and when not connected to the condenser. During operation, the lid connected to the condenser is placed at the pot to close it. When the water is heated, its steam extracts essential oils which then travel with it out of the pot and through the 32 x 1.5 mm pipe. The steam is then condensed at the cool wall of the water jacket and the condensate is collected in a separating funnel. The condensation is achieved by pumping ice-cold water into the water jacket through the inlet of the condenser. After cooling the steam, the heated water then comes off the water jacket and the process continuously repeats itself until the steam distillation is stopped. The hot water is pumped into the water reservoir which is cooled by ice and pumped back into the condenser chamber to cool the steam again. This cycle is repeated continuously. The biomass to be extracted is placed on a sieve on a stand in the urn/pot above the water generating steam, i.e. the material shouldn't touch the water. The plant material must be loosely layered and evenly spread in the sieve, receiver, so that the steam evenly reaches all parts of the plant, no channel formation. Make sure the lid is tight and securely closed with the clamps. Measure the temperature of water. Temperature should stay as low as possible, room temperature or lower. A lot of water is needed for cooling, so use the drain at the bottom of the condenser to save and reuse it. Ice is added to the cooling water to lower the temperature of water. Use low heating temperature. The too high temperature will destroy the essential oil, it is too low and doesn't boil. Keep the operation going until the water from the boiler is almost fully evaporated. The whole process takes from 1 up to 12 hours. If one does a water distillation, the plants are immersed in the water, the fire must be medium to low to avoid burning the material. Use a separating funnel to separate the essential oil from the hydrosol underneath. Excess water can also be separated by freezing the oil. After the steam distillation, the plant material can be used for extraction of useful chemical and/or dried and used for biochar production. Energy source with continuous 4 to 10 kilowatts. Small parabolic mirrors probably do not provide enough energy. Other energy sources may be more efficient, such as photovoltaic and biogas. Diffusion of essential oils from seeds into steam is very slow and leads to long distillation times, days. Therefore, seeds, such as fennel, should be crushed before distillation. Over the distillation time, the yield of essential oil decreases continuously. In practice, an optimum must be found between energy consumption and yield. Picture A shows the gum resin of Commiphora on the stem of the tree. In Picture B, the resin harvest is ongoing. The collected gum resins are stored in plastic bags and pounded before undergoing steam distillation. This table shows the parameters that should be measured for each distillation process. Finally, here are shown the contact information of the technology and manual providers.